Hello, everyone. So today we're going to talk about Chapter 4, Section 1, which deals with events and sample spaces. I went ahead and started writing some things down because I didn't want to bog us down with just writing stuff. So the first I want to define is an experiment. And an experiment is nothing more than a process by which an observation or measurement is obtained. Now, when we talk about experiments, there's basically like two types. There's an observational, which you just sit back and watch. All right, so you are not in any way involved in the experiment whatsoever. You just sit back and watch. This could be maybe you're interested in the number of people that stop at a stop sign in your local neighborhood, so you will just post up a chair, pick a time to sit there, and just record. Did they come to a complete stop? Yes or no? And you could do that all day long. Kind of boring, but people do that. The second type is an experimental type of experiment, and this is the case where you have a control group and a treatment group. Within a control group, maybe you give them like a placebo, and the treatment group actually gets the medicine. Okay? So now, once you start thinking about, okay, well, I want to do, let's say, an experimental type of study. Now you need to decide, okay, well, what are going to be your simple events or just a regular, or just in general an event? So let me explain the difference here. A simple event is the outcome observed on a single repetition of an experiment. An event is just the collection of the simple events, okay? So an example that I have here is this. An event would be tossing a coin 3 times and recording heads or tails per toss. The simple event would be each individual coin flip, okay? Now, if 2 events cannot occur at the same time, we call them mutually exclusive. All right. So, for example, let's say you were taking a quiz. So here's your quiz. Question 1 is a true/false question. Question 2 is multiple choice. All right. You cannot do both of them at the same time. So you got to do the true/false question first, or the multiple choice question first. But you can't do them at the same time. So these 2 events are mutually exclusive. Now, if you were to collect all of your simple events, what you've just found is what we call a sample space. So here I drew a little 6-sided die. Now just remember, all dice or die, remember dice is plural. Die means you only have 1 in your hand. And all die have 6 sides. So your sample space is going to be 6, okay? The simple event would be rolling a 2. Now, sample spaces always get a capital letter. In this case, I'm going to label this S, and for this specific example, my sample space is going to be 1, 2, 3, 4, 5, and 6. These are all my outcomes, or possible outcomes. Let me write the word possible. All right, those are all my possible outcomes there, okay? And notice I have a total of 6, and that's why I wrote 6 in the upper right-hand corner. All right? Now, there are multiple ways that you can kind of, write out sample spaces. And there is no right or wrong way. It's honestly, it's what works for you. So, for example, here, we call this the list roster method. And you are not going to find those words in your book. It doesn't say that. All right, I'm just telling you it's called the roster method. You were just writing out all the outcomes. All right? Let's say you have something that's a little bit more complex. Let's say you were rolling 2 dice and want to find all the possible outcomes for the summation of the die. All right. So a lot of us may sit there and go, well, you on the first die you can roll 1, on the second die you can roll a 1, so that totals to 2. Then the first die you can roll a 1, the second die you can roll a 2, that totals a 3. And you can keep doing this by keeping the first die static and allowing the second die to change. Oops, sorry, moving too fast. All right, and then you'd have to do all this for the first die being a number 2, and the first die being a number 3, and so forth, okay? So that's one way you can do this. Now this is, I like to call this the method of exhaustion, because when you are done, you are just exhausted, okay? Another way to do this is by using a table. So the column represents the first die, the row represents the second die, and since you are just rolling the die and then adding them up, what you can do is you can sit here and do the same exact thing what I just did. So I rolled a 1 and a 1, so that adds up to 2. Now I roll a 1. Sorry, let me do this again. I'll use a different color this time. So I roll a 1 and a 2. That adds up to 3. Now I roll a 1 and a 3, and that adds up to 4. And you can do this all the way down. Now, excuse me. In the previous video, when I was talking about correlations and everything, I made a comment about mathematics. And I said mathematics is the study of patterns, all right? It was in the correlation video all the way at the end when I was talking about predictions, and math allows us to, or regression lines help us to make predictions and stuff like that. So if you can see what I am doing here, I have found a pattern. Notice in the first row, first column, it is 1, 2, 3, 4, 5, 6, 7. And then in the second column, it is 2, 3, 4, 5, 6, 7, 8. And then in the third, it's 3, 4, 5, 6, 7, 8, 9. Well, once you find a pattern, run with it. So as you can see here, I am just adding these numbers up very quickly because I found my pattern. 8, 9, 10, 11, 12. And I guess I can make this very first 2 a red 2 now. And as you can see here, I have found all the possible outcomes when I roll 2 dice and I add up their total. In this case, my sample space is going to equal a total of 36 possible outcomes. Okay? So if you were to use this method of exhaustion over here, you would have to do this 36 times. Like I said, you could do that if you want. You might be a little tired at the end, but that's okay. Now, the last way, and this is not like the only, these are not the only ways. These are just the ways I'm going to show you. There's more, and you can create your own, whatever works for you. The last way is called a tree diagram. Okay? So a tree diagram, basically, you start off with something, and then you build off of that with different outcomes, okay? So like, for example here, we're going to keep this really, really simple. You go to Subway, eat fresh, to order a sub. All right, so you're pretty hungry, it's lunchtime, you want to go to the Subway. Now, at Subway, and this is a very, it's a brand new Subway, and they don't have a lot of stuff. So I'm kind of forcing this to be small. So at Subway, you have 3 protein choices, 2 cheese choices, and we'll say 3 dressing choices. All right. This Subway is so broke it doesn't even have vegetables. All right, a boring sub. Now, if I wanted to find all the possible different outcomes of the subs that I could create at this Subway, I can go ahead and create a tree diagram. So when you think about when you go to Subway, the first thing they ask you is, we'll keep it even simpler, what protein? Okay? And like I said, you got 3 choices. You have, we'll just say turkey, we'll say seafood. I know they make a seafood sub there. And then the last one, we'll say meatballs. All right? Now, you can only get 1 meat per choice. Like, we're not combining anything here. We're keeping this very simple. All right? Now, the next thing they're going to ask is, what kind of cheese would you like? So, cheese. And then from here, you have two options. You have American cheese or Swiss. And you can have that for each sub. So American or Swiss. And then American and Swiss. And last is going to be dressing. And you have three options here. So let me give myself a little bit more space here. One, two, three. And these dressings are mayo. What are the dressings? Ranch dressing. And what would be another one that people like? Let's see, mayo, ranch, and chipotle. They have that chipotle sauce. It's pretty good. So notice you have that for each one of these. Now you can already start to see a disadvantage of a tree diagram. The disadvantage is it gets large very, very quickly. All right, so just let me label this real quick. And what you can do is on the very end of this, you can start to label all of your subs that you can make, and then you count them all, and that's your sample space. So like, for example, and I'm only going to do the turkey ones. We're going to have turkey with American cheese and mayo. You can have turkey with American cheese and ranch. You can have turkey with American cheese and chipotle. You can also have turkey, excuse me, with Swiss cheese and mayo, turkey with Swiss cheese and ranch, and then turkey with Swiss cheese and chipotle. So just for the turkeys alone, you have 6 total combinations. All right? Now, that means for the seafood, you're going to have the same basic setup. So, seafood, American mayo, seafood, American ranch, seafood, American cheese. I guess I might as well just do it for all of them. Now I'm feeling the flow. So we have seafood, Swiss with mayo, seafood, Swiss with ranch, and seafood, Swiss with chipotle. And then the last one is going to be meatballs American with mayo, meatballs American with cheese, meatballs American with ranch, which would be disgusting. Meatballs Swiss with mayo, meatballs Swiss with cheese, and then meatballs Swiss with ranch, which honestly I think that I don't know. That or the seafood with Swiss. I don't like Swiss cheese at all. I think those two would be the most unappealing to me. But notice for each one of them you have a total of 6, or you have a sample space of 18 outcomes. Now, like I said, tree diagrams, advantage, you can see everything, and it's fantastic. Disadvantage, when you start to get a lot of options, you're going to have branches all over the place, okay? So you got to be really careful when it comes to tree diagrams. And that's going to be it for this video. It's just all about events, sample spaces, and how to find them. I will see you in the next one, which deals with calculating probabilities using simple events. And that is basically, it's what you're used to seeing, okay? So I'll see you in the next video.